Welcome, madam. So everyone, welcome to day 4, lecture 2 and session 7. Already our honorable speaker, Dr. Sagarika Pal, head and associate professor of electrical engineering department of NIT Kolkata, has already joined. So before for the going to the sessions, first let me check. Madam, please, are you able to share the slide, please, so that we can check everything is going fine. Yes, ma'am.
Is it okay?
Yes, ma'am. It is perfect. Just go for a full screen. That's slide mode, slideshow mode. Yes, ma'am. It is perfect. Just give me 2 minutes. Let me finish your bio with your bio.
Is
Then
it
I'll hand
changing?
over the
Slides
session to
are
you.
changing?
Yes, ma'am. Slides are changing. Everything is fine. This side.
Okay.
Thank you. So, good afternoon to everyone, all the participants. Thank you for joining on time. We are here with our honorable speaker, Dr. Sagar Gopal, head and associate professor of electrical engineering department from NIT Kolkata. Before beginning the sessions, let me introduce Dr. Sagar Gopal, who is also my guide as well. So it's my honor to, I'm privileged to honor to present about the bio of my guide itself. Dr. Pal is currently an head and associate professor in the Department of Electrical Engineering of National Institute of Technical Teachers Training and Research, Kolkata, India. She obtained the bachelor degree in instrumentation engineering and master degree in measurement and instrumentation from University of Kolkata, India. She completed her PhD in engineering from Jadavpur University, India. She has won patent application publication on improved robotic gripper in the Patent Office Journal, India in 2009. She has also published her works in multiple national and international journals, including conferences as well. Her research area of interest is in sensors and instrumentation, control, robotics, and mechatronics. So thank you very much, ma'am, for coming and presenting in this and for the excellent topic what we have just provided to us. Now session is all yours, ma'am. Please.
Thank you, Dr. Shamantu, for introducing me with the participants and also for giving me the opportunity to share some of my knowledge with the participants. Now, during my presentation, on any slide, on any discussion, if you have any query, you can stop me and you can ask the question at that moment. No problem. But I want that the session to be an interacting one. You please interact with me whenever you will have any question or anything. Okay. So let us start the session.
Yes, ma'am. Yes, ma'am. But ma'am, your slides are not visible,
Yes,
so I
yes,
think.
I have not shown that. I think the screen is visible
Perfect.
to you.
Yes, ma'am. Yes, ma'am. Everything is perfect.
Okay. Now, title of the topic today, what we shall discuss, that is significance of sensors and IoT for industrial automation. Here, some keywords are: one is a sensor, another is your IoT, and then industrial automation. We shall just correlate these three terms, right? So,
Ma'am, your voice, it is not coming, ma'am.
am I audible now?
Yes, ma'am. Yes, ma'am. Now you're audible.
Some network issue was there, and that is why I was disconnected. Anyway, let us start from the beginning. So, the topic which we shall discuss today is significance of sensors and IoT for industrial automation. From this title, what we are observing that three keywords are there: sensors, IoT, and industrial automation. We just correlate these three terms for our in this particular session, and then we will see what will be the advantage of this industrial automation with the sensors and IoT. Okay. Now, sensors and IoT actually in industrial automation is revolutionizing the industrial part. Okay, and we will see how this connection is there. That is how sensors and IoT are connected with industrial automation system. Let us first define what is industrial automation. Industrial automation is the use of control systems. Basically, automation implies a typical type of control system. Control system may be through using computers in the robotics area, and also information technology is also there for handling the different processes, machineries, and finally our target is to replace the human being. And in a better way, we should have the control mechanism, right? And industrial automation technology provides the companies with enhanced security. So security part is a very vital part. In industrial automation technology, this security part must be maintained properly. At the same time, our target is to reduce the cost, better product quality, and so on. So all these advantages are to be there whenever we will connect sensors and IoT with the industrial automation system. And finally, the target will be that the companies will be able to increase their profits and productivity. At the same time, quality of the product. Okay. Now, any industrial automation is associated with some control mechanism. Okay. And this is also called industrial control system operation. That's some diagram I am showing here. You see that this is a schematic diagram how the automation is achieved. When if you think of about the industrial automation system, that is several control loops are there. Thousands and thousands number of control loops are there. So all the controllers in the loop just looks like this form. Schematically, I am showing here. Controller is there, and any process or any parameters who are changing, where there is a change, that parameters will be controlled. Okay. Process means where some changes are going on, some parameters changes are going on. Suppose you are sitting in a room, the temperature is being controlled by your air conditioner. So your room is a process. Okay, your room is a process and the temperature is the parameter which you are controlling by using your controller. Control temperature controller is your AC machine. Now in the control process, you see that several number, that is within the process, the disturbances is also there. Disturbances means what? Suppose you are in the room is absolutely at the temperature what you have set through your remote, but at that moment some people have entered into the room, they have opened the door. So what will happen? Then from outside some hot air will enter into the system. Initially the system was in the steady state condition, but whenever a lot of people are entering into the room, automatically the system will be disturbed. So disturbances will be observed. Okay, so temperature will actually increase from that of your, or it may decrease also. So that is some deviation will be there from the desired value which you have set from your remote. So in your system, your room is the process. Process input is your cold airflow and output is that temperature of the room. That is the output. Process output is the temperature itself. Now, how far your temperature is being maintained in your system? So temperature will be sensed by some sensors, and it will send the signal to the controller that temperature has been deviated, that error has been generated. The controller, maybe different types of controllers are there, but whenever the error will be there, then controller will do some control action, some changes, some mathematical operations will be there, and finally it will generate some output, and that output will go to the actuator part. You see that in one side of the controller there is a sensor output is going to the controller output is going to the actuator, and actuator is basically responsible for controlling the process. In this case, the actuator function of the actuator is to decrease or increase the cold air flow into the room for this room heating system or room cooling system rather. Now you see that in normal industrial control operation, there are some human machine interfaces also there. That means several such closed loop operations are going on in the system. So several such units means several such closed loop control systems are there, thousands and thousands loops are there, but all the loops are to be monitored to have the condition of the process to be maintained properly, proper quality of the product, achieving the proper efficiency, energy efficiency, and so on, everything. So it is all these loops, thousands of such loops will be monitored, and monitoring operation will be done by some human machine interface. That is, some interface must be there, some screen must be there. There the operators will be able to see what is going on throughout the plant area. Okay, and after, if it is observed that in the plant some disturbances are there, then some remote diagnostics or maintenance part must be observed, must be done. Maintenance part must be done. That is, some loop is not operating properly, any controller is not tuned properly, so any diagnostic or maintenance operations will be done. So you see that in this type of system a lot of information flow is there. Okay, information flow, that is data flow. So data flow is there. Within the process, the temperature data, for example, say it is the temperature. The temperature will be sensed by the sensor, and sensor data is being supplied to the controller. So data flow is there. Then controller output, that is also another set of data that is also flowing to the actuator. And how far the controller is operating, that will be observed by the human machine interface. That is, some operators who are actually observing or who are looking after that HMI software. This is also achieved by some software. Okay, so human machine interface software that will be looked by the particular operating personnel who will be sitting before that monitor to look after the overall process operation. So everywhere you see that there is some data flow, and that data must be, that is on the basis of data, getting the data and then analysis of the data. On the basis of analysis of data, some action must be taken, say remote diagnostics or maintenance, some action may be taken. So apart from these blocks, the flow of data from various points, one point to other points, is also necessary to have the complete industrial control system operation. In the same way, you can see that this diagram is showing the automation hierarchy. That is, in any industrial automation system, the automation hierarchy must be maintained. What is the automation hierarchy? It is just like a pyramidal structure you are observing here. And this structure is containing several levels. Level 0, level 1, 2, 3, 4. The lower one is the field level. Field level is basically containing the field instruments, say different types of sensors, transducers, etc. And you see that it is a pyramidal structure. So the area is maximum at the base. If you just see the area of level 0, the area is much larger than level 1. So this is the field level. That is, field instruments are there. Field instruments are there. From there, the data is going to the control level. Several controllers are there in this level, level 1. Now, to operate the controllers in the optimization level, that is You have to see the controller output, how better way the controller can perform. All these are based on some calculation. So that is your optimization. So this is next level is your optimization level. This level will also take the data from the control level as well as from the field level, and they will optimize how far the controllers can work efficiently. Okay. Then it is the production level, that is production, planning, scheduling. All these operations are done here, and data is flowing from bottom to top. And further, it is your corporate level, that is management information. So management information is such that here the data he can see, that is the person who is in the top level, he can see the output from every level if he wants. So basically, this automation hierarchy indicates that some data flow must be there. That is, information must be shared by one level to other. Okay. So this information is not only the information but also analysis of information data, or after analysis it is to be the proper appropriate use of that for your optimization or for betterment of the product, for efficient operation. All these things are actually to be done. So naturally this communication part is very important part, apart from all these different sensors, transducers, controllers, etc. Okay. Now let us come why IoT is there needed in industrial automation. What is the role of IoT? You know that IoT is nothing but Internet of Things, which has become popular in the tech sector over past few years. It has been very much popular. And previously, Bluetooth and radio frequency technologies were used to control and monitor the industrial applications, but it was actually short distance communication. Now, to avoid that short distance communication problem, IoT-based industrial automation system has come. That is to integrate IoT with the concept of industrial automation. Okay. Now, how is it possible? Because a lot of physical devices are there, sensors are there, controllers are there, that we have already seen in the different last two diagrams. So all these devices and other different objects, in case of your industrial automation, they are able to communicate with each other. The devices will be able to communicate with each other over the internet. Because everywhere the sharing of data is needed. In the automation hierarchy, you have seen that sharing of data from one level to other is very important. Okay. And not only sharing, but analysis of data at different level is also another important task. So if the devices at different levels can communicate with each other over the internet, then the communication part will be much easier, and it has been observed that in this way IoT is changing the way we live, we work. Okay. So IoT is the process of connecting common objects to the internet and utilizing the data produced by those objects, and this will improve simplicity and the very important aspect, that is the security. Data security is also to be maintained. That security part is also there. And effectiveness for daily lives and also in the industrial field, right? And at the same time, it is quite clear that IoT in industrial automation allows for remote monitoring and control of machinery and processes. So that means remote monitoring, that is the system is operating here. The person, suppose the system is operating in the level 1 of the automation hierarchy, and at the level 4 person, they want to monitor what is going on in the field level, in the controller level. So that is possible also through IoT. That means the operators can oversee operations from anywhere in the world. It is not that the person is sitting within the plant area. They may sit anywhere in the world, and the devices will be connected to the internet, and finally the person will be able to see what is happening in the plant area. If any fault condition has appeared in the plant area, the person may be anywhere in the world, he can see what is the fault and when it has been detected and how far it has been actually corrected. Anything can be observed regarding the plant for industrial automation. That is, industrial field operation can be observed from anywhere in the world through your internet or IoT. Huh? And also, it is to be mentioned that the fourth industrial revolution, you know that industrial revolution 1, 2, 3, 4, 1.0, 2.0, 3.0, 4.0, and so on. So industry 4.0, that is fourth industrial revolution, is being fueled by IoT in the context of this industrial automation. Okay, so this is very much this is our actually the great achievement. And IoT is revolutionizing manufacturing industry, any process industries, through real-time data collection, data analysis, predictive maintenance, that is anything is to be going to happen in near future that that can be predicted or maintenance can be done. Any smart factory environment can also be created through by using IoT. So all these are different applications of IoT for revolutionizing any manufacturing industry or any other industrial automation area. And through this, profitability is increased, innovation concept has been, and efficiency, innovation and efficiency both are increased, right? So what are the advantages? Point-wise, I can write that higher production rates and increased productivity, more efficient use of materials, better product quality, improved safety, shorter workloads for labor, and reduced factory lead times. So these are, that is, multiple number of advantages are there with normal automation. And when IoT is incorporated here, so that will also revolutionize the overall automation system. Okay, so you know that automation includes various control systems such as within the factory, machinery, boiler, heat treating ovens, steering, etc. So many devices are there where automation is needed, and there we can integrate IoT also. And you see that this is manufacturing industry. It is showing car manufacturing industry. Many robotic arms are actually being utilized here. At the same time, all these robotics arms are responsible for doing the welding on the metal body. Okay, so many things are being operated. So some synchronization is there, and everything is automated. Some controlling operations are there, and whatever is going on here, that can be, the data can be monitored, that the data can be shared, or data can be actually observed, analyzed for betterment from anywhere if IoT is associated with it. Okay, so of course safety is a factor because data will be transmitted to far place, but safety of data must be there, right? So any automation system, basically this part, this loop part, I have already shown to you. That is sensors, plant, actuators, that is control policies. Yeah, what type of control policies, that will be determined depending on the type of the process. Okay, and output of that control policies is actually going to actuator and plant instantaneous value will be sensed by sensor, and it is also going to the control policies. And also this is actually supervisor. It is actually supervisory computer. In SCADA system previously we have used that supervisory system where supervisor will the decision maker. He will take the data, that is supervisor will take the data from the instrumentation of the plant, and from there he will give the commands and also can change the control policies. So this is your block diagram for your automation system. Now, what are the different components we have already seen in the diagram? That I am just showing just point wise. Huh? Sensors and instrumentation, that is one part. What are the different sensors? Temperature sensor, pressure sensor, flow sensor, level sensor, or any other humidity sensor, gas sensor, anything, any sensor can be there. Also, there may be some controllers like programmable logic controllers, DCS, distributed control systems, SCADA systems, supervisory control and data acquisition system. This is also one component. Communication and networking. Communication and networking part, this is actually something, this is actually contains a typical communication system for the level 0. Level 0, what you have seen, that field level. I have already mentioned that automation hierarchy. In the field level, sensors, transducers are there and actuators are also there in the field level. And there, actually communication is done by field bus system. This is actually international standard field bus system is used in plant area. In actual plant area, field bus system accommodates the sensors, that is the devices can communicate with each other through this field bus system. Profibus, Modbus, all these are very common field bus architecture used for your level 0. And also human machine interface, this includes the operator interfaces such as your touch sensors, graphical user interface. This is also another component. So all these are in the field level. Okay, all these are actually, that is in the plant level, in the plant area, right? Now, power and energy measurement management, that is also to be there, because everywhere we need the efficient energy utilization system. So power and energy management must be there. Safety security part is also there, that is safety of the instrument system, any safety from fire and gas, safety for security for data, all these are ensured in the plant area, right? And other very important component of automation is your data management and analysis. That is basically it is called data historian. Data historian contains the different data, a lot of data generated by the sensors, controllers, etc. All these things. Okay. So data management and analysis, that is there. Any reporting or analytic software that can capture, store, or analyze the data, that data management analysis is also a vital part for automation in the plant area. Any remote monitoring and control, that is remote access, telemetry, remote diagnostics, all these are also needed for remote observation of what is going on in the plant, right? Now, you see that typical sensors used in industrial automation, previously also I have mentioned that temperature sensors, pressure sensors, flow sensors, a lot of different sensors are listed here. Force, position, acceleration, light, sound, etc. Now, today, the sensors are available with some inbuilt signal conditioning circuit. Today, it has been very much helpful for us to use the sensors. Just you can purchase the sensor from the market with some specification. For example, say ultrasonic sensor, gas sensor, alcohol sensor, and then color sensor, light sensor, proximity sensor. These are commonly available or commonly used sensors for different applications. Now, one thing you see that these sensors also contains, that is sensing element is there. Element is not visible from outside always, but sensing element is there. At the same time, the actual sensing element, that is the element which will actually sense the parameter, measurement. If it is a gas sensor, then some element is there whose resistance will change with respect to the gas concentration. Presence of alcohol will change some parameter of the sensing element. Similarly, light sensor, some variable resistance may be there. So in most of the cases, the sensing element may be a variable resistance type, variable capacitive type, variable inductance type, or some other different types of sensors are there. But here you see that the sensors which are available from market, they contains not only the sensing element, but also a small PCB board attached with it everywhere. You see, that means it will generate that is sensing sensor part output, sensing element output that is not usable properly, but whenever it is used with some small signal conditioning circuitry, then it will be easily accessible. So today, whenever you will purchase any sensor, the advantage is that the signal conditioning circuit, small signal conditioning board, PCB board, is attached with the sensing element. And it has its standard terminals. If you give supply to these terminals, say one terminal will be ground, another terminal will be your plus supply, and other two terminals will be the output of the sensor. So you will get standard voltage signal or standard current signal, okay, with respect to the measurand. Measurand means it may be temperature, it may be gas, it may be distance, whatever it is, color, light, etc. Okay. So this is one advantage. Now you see that these sensors are actually contains the sensing element and signal conditioning circuitry, which is giving you some voltage or current signal. But can we tell them as an IoT sensor? Or is this sensor can be used for IoT application directly? Directly you will not be able to use it, because IoT means the sensor should communicate with the internet. So these are the bare sensors. They can give you the voltage signal. But you have to use that voltage signal for sending it through internet. So some extra module will be actually attached with this type of sensor so that you can use it for sending the data from sensor to some through internet to some other part, any part of the world, anywhere in the world. Okay, so these are the bare sensors. These sensors will not be the IoT sensors. For use it in IoT application, you must have to modify it. Okay, so if in the process for industrial automation system, in the field device, in the level 0, a lot of sensors are there, these type of sensors are there. But if you want to use the sensor output to be sent or to be received from any other part of the world, then you have to modify the sensor circuitry. That is, you have to use some separate module. Okay, for example, say this is one soil moisture sensor. Okay, soil moisture sensor. This sensor will actually its type is variable resistance type. So if soil moisture level is high, that is your moisture level say changes from 20% to 50%, 60% or like that, then its resistance will change. Okay, and this change in resistance must be associated with some signal conditioning circuitry, some voltage signal will be there. Then that sensor data for its transmission, data may be transmitted through Wi-Fi. Okay, so we can send the sensor data to another part, that is the control center. This is the controller part, this is sensor part. I have already shown to you in the automation hierarchy that field 0 is sensor, field 1, level 1 is the sensor, level 2 is the controller. So here you see that the sensing level and controlling level, there the data is being transmitted through Wi-Fi. Okay, so sensor part is there, and with the sensor part, some Wi-Fi module must be attached with it, and then the sensor data can be sent to the controller part, control center. If you want to send the data at some remote location where the controller is situated. Now here after control action, the data analysis will be done, and from there it will be concluded that what is the moisture, soil moisture existing, and what is the required amount of soil moisture. On the basis of that data, the actuator is your water pump here, that may be switched on or off for pumping the water into the soil as per the requirement. Okay, so whatever is going on here, that is your sensor data is transmitted through your internet, and then it is going to the control center, and controls actuator is actually located in the near the soil, because actuator is the water pump. So pump will be operated in the level 0. So sensor and this actuator is in the level 0. Control center is in the level 1. And that communication is being done through your Wi-Fi. So from your remote area, the actuator can be actuated depending on the control center data. Depending on this, if it is automated system, then automatically the actuator will be initiated anywhere in the world. Any operator in the situated in the anywhere in the world can see what is going on, what is the soil moisture existing, and whether the pump is switched on or not, switched on or switched off, that can be detected, that can be observed, whether the soil moisture is maintained at the proper level or not. All these data can be observed if the data is through Wi-Fi is connected to the user. Okay, that is, user will be able to see the data. So if you want to use this type of system, that is, so many sensors are there, so many controllers are there, actuators are there. So if a number of such sensors along with these actuators are needed, so we need some sensor node. A large network among the sensors is needed. Through IoT, those nodes will be connected. Okay, and those sensors or devices will be used to communicate with each other so that the data can be collected or transferred over the internet. So then we call it as a connected sensors or IoT sensors. These are also available in the same thing is available in the smart factory. So sensors are essential component building blocks in the smart factory environment. Of course, maximum in the level 0, it is maximum area in the pyramidal structure that I have shown to you. So maximum number of sensors and actuators are there. So all these sensors are giving you the actual plant information. So that sensor data can be transmitted smoothly to different parts of the plant as well as from anywhere in the world. If you want to see the data or the plant operation, then it is possible through IoT, and then it will be a smart factory environment. But one thing is there, that safety. Safety of any plant information must be very safe. That should not be disclosed to others. So safety is also one part. At the same time, whenever we are implementing that sensors to IoT sensors, then that data must be kept safe. Okay. And you see here in the smart factory environment, some sensing nodes are there. A lot of sensor nodes are there. You see, all these sensor nodes are what? I have already shown to you that sensors connected with small signal conditioning board. And whenever those sensors will be connected with Wi-Fi module, say, for sending the sensor data to the remote location, then it will be a sensor node. So one node may send the data to the other node and so on. And this way there is one sync node, and from the sync node, ultimately the data will be available to the user from cloud. Okay. So this is actually wireless sensor network. All sensor nodes, all these are sensor nodes connected with each other. Okay. And they are also connected with the cloud. And data from these nodes can be transmitted to the central server, where it will be defined and it will be made available to the user. Okay. So you see that these are the different sensors. Also, these sensors are mounted with Wi-Fi module. And whenever these Wi-Fi modules are there, they will be actually able to send the data to the internet, and users will be able to see the sensor data. User may be anywhere in the world. Okay. So what are the characteristics of this sensor node? This is a network. Basically, this is a network which is capable of performing some processing, gathering sensory information, and communicating with other connected nodes in the network. And this neighbor node will relay the data to the another node. Okay. And gateway is what? It is also a node, which is the router in the computer network, which is a key stopping point for data on its way to or from other networks. So many networks are there. So it is the sink. Okay. Now, sensor node contains, previously I have shown you only the sensing unit. Processing unit, sometimes it is accommodated with the processing unit. That is, small PCB boards are there. but not with always all sensors. If you, I'm just going into that sensing part, you see that small PCB board or signal processing board is there associated with the sensing element. But here it is LDR sensor. Here only two terminals are there. When light emission is there, then its resistance will change, light dependent resistor. But here no any small PCB board is there to convert the change in resistance into voltage or like that. So in market available sensors, always you will not get this small PCB board for your processing the data. You have, sometimes you may have to develop your own circuitry for getting the appropriate voltage data from the sensor. Sometimes it is needed. Okay, so if you just see the sensing nodes for transmitting the sensor data through internet, then sensor node components are sensing unit that I have already shown to you. Processing unit, sometimes processing unit is inbuilt with the sensing unit, sometimes not. Communication unit, that means Wi-Fi module must be attached with it. So that is your transceiver, transmitter, receiver. Then ADC, analog to digital converter, power unit, and other optional units such as detecting location, etc. So here through diagram I am showing you, this is bare sensor. No processing signal, processing of signal is there. Now any analog sensor data may be amplified, then it may be converted to digital one, then it will go to the microcontroller for its required say complement, some compensation, sometimes amplification, and so many activities. That is for processing of data. You need some microcontroller unit, and also it will the microcontroller unit must be associated with your transceiver unit, and finally it will go to the cloud server. You see that same thing is shown you in the block diagram. This is the physical measurement by any analog sensor. The data will be converted into your analog, that is converted to digital data by using ADC. ADC is connected with your microcontroller unit. It has its own memory, and microcontroller unit is also coordinating all these transmission and receiving of the data through this transceiver. So this is your radio transmitter transceiver. This is your Wi-Fi module, must be mounted here with this particular microcontroller unit along with memory, ADC, etc. And power supply, of course, is to be there. And through this antenna, the signal, that is sensor data signal, must be transmitted or received from anywhere in the world. So this is your, sometimes we call it as a smart sensor, but smart sensor with your Wi-Fi module, right? Now several mechanisms are there for traveling of sensor data from one device to cloud. That history I am not discussing now. Now for data transmission to cloud, that part I shall highlight. You see here in this diagram, this is your sensor data, and the data is actually connected with the data acquisition system. This is also called DAC device. That DAC device, of course, in between this sensor and DAC device, there is some processing part, that is signal conditioning part is there, signal processing part is there, if the sensor is not containing the signal processing board. Now after DAC device, the data is available to the computer, okay, and from there you can send the data to cloud. Storage is there, so data logging, data monitoring can be there. Now from this cloud, the data can be available by the user through net. Okay, and this actually is your sensor data transmission enabled by cloud API, application programming interface for IoT gateways. Now basically from sensor to cloud, a plug and play approach is actually used very frequently today. API, application programming interface, is a connection between computers or between computer programs. It is a type of software interface which is offering a service to other pieces of software. Okay, So this API also called API key. Previously, just I'm showing you this part, this one. Also called your cloud API. It is application programming interface. That is interface, software interface in between your sensor data and cloud, right? And there is one API key because it is a software interface. So it, for data security, we should have some API key. Authenticating key it is, and this must be known to the user if the user want to see the data. This API key is an alphanumeric key, and through this API key you will be able to send the data to the cloud, or you can access the data from the cloud, both. So this key is your authenticating the use, that is safety, data security and safety is maintained through this API key. Now some more details. You see that basic API functionalities, that is establishes a connection between computer systems and enables the data accessibility. So basically this is the database. These are the end users, right? And your API key is the interface between this side and this side. So whatever data is there, if the user has the request of that data, and that data will be accessible through the user through this API key. Okay, so this is the safety part, that through this safety, the data that is API alphanumeric key, if it is known to the user, then you will be able to access the data, right? Now, how this type of system can be implemented? We can implement it in our laboratory also. That is how the sensor can be converted into IoT sensor. If the data is to be sent to the cloud, the data may come from sensor, data may come from, or data can be sent from sensor to cloud, or data can be sent from controller to cloud. That is, the cloud will contain the data from sensor or cloud, and from the cloud the data is accessible by the user. There may be different types of communication possible, but by using Wi-Fi module, by using API key, it has been done very easily in our laboratory for our students, projects, and so on. Okay, and this is ESP8266 Wi-Fi module. This is easily accessible by the students, their project work, their research work, and so on. Okay, so basically this is the device which enable us to receive and transmit data from sensor side or whatever that is data source, maybe sensor, maybe controller, whatever it is. And if you consider the automation part of industry, then it may come, the data may come from sensor, data may come from controller, from anywhere. Okay, actuator also. Anyway, the data will be transmitted to the cloud through this ESP8266 Wi-Fi module. So Wi-Fi module connects the whole process to the internet. Okay, so this is very popular Wi-Fi module. Apart from this, we can also have Node MCU, that is Node Microcontroller Unit, which is also a open source software and hardware development environment built around using this ESP8266 chip. Actually, this ESP8266 is inbuilt within the system. This is actually Node MCU, Node Microcontroller Unit. Because whenever you will be sending the data from any data source, any sensor type, sensor side or controller side, whatever it is. Previously, I have mentioned in the diagram, if you, I'm just going into the diagram, say this is the physical world from where the data is to be transmitted. It may be sensor, data may come from sensor or controller, whatever it is. Then it will be actually from, it will go to the ADC, then microcontroller unit, and you see that the microcontroller unit must be associated with some radio transceiver. This is your Wi-Fi module. And some application programming must be there. If you incorporate the API key in the software, then you will be able to send the data to the cloud, or from the cloud you can access the data. Okay, so microcontroller unit must be associated with transceiver, and that is why you see in this case, in this node MCU, that task is being performed. So here your one pin is there for analog input, and from there the data can be transmitted to the cloud. But previously also I have said that this ESP8266 Wi-Fi module can be used, and that module is inbuilt here. This is Wi-Fi. You see that this is your Wi-Fi module and this is the antenna. This is your antenna, right? So this Wi-Fi module along with this microcontroller unit, those are actually coupled together. So that is why it is very much easy to use, right? So data can be transmitted to the cloud by using this Wi-Fi module. So this is one option. Other option is that using students are very much familiar with Arduino board. Okay, Arduino board, actually this is containing your microcontroller unit as well as this. The difference with this Arduino board and with the node MCU is that node MCU contains this Wi-Fi module. So if you just use the sensor data with this Wi-Fi module, then node MCU, then the sensor will be your IoT sensor. That is, the sensor data will be transmitted to the cloud through this Wi-Fi module. But in this case, it is specifically this Arduino board will act as a microcontroller board. Okay, the data acquisition board rather. There is no any Wi-Fi module here attached. Okay, so Arduino board can be used for data acquisition, or you can take the data, you can see the data, but you will not be able to transmit the data. So for that part, you have to couple with this Arduino board with the ESP8266 module, because this chip is ESP8266 is capable to send the data to the cloud or take the data from the cloud to the system. Similarly, Arduino Mega, here also a lot of different input channels are there, but sometimes the ESP8266 module is not attached with it. If it is attached with it, then it can be used for, not always it is in Arduino Mega. Sometimes we see that several number of channels are there as a data acquisition board, but not always ESP8266 module is there. But once ESP8266 module is there, then you can use this module to transmit the data. And you see, this is one design of Arduino with coupled with ESP8266. You see that this is Arduino board. It is WeMOS D1. This is also called WeMOS D1. This can be used for sending the data to the IoT platform or your cloud, right? So this is your Wi-Fi module. If Wi-Fi module is attached with it, then it is much easier to write the program and easily. And within the program, that API key must be incorporated, right? And this is how the normal Arduino board, where the ESP8266 module is not coupled, but it can be connected with the ESP8266 module. This is the circuitry connection that has been shown here. But sometimes if it is inbuilt with this Arduino board, just like this previous one, then it will be much more helpful for sending the data to the cloud, right? Now I am coming to the platform, IoT analytics platform, where you will be able to send the data. That means from your Wi-Fi module, the data will be transmitted to some platform. That is, maybe a ThingSpeak platform. ThingSpeak is actually an IoT analytics platform. This is actually, this service is obtained from MathWorks. You know that MathWorks is, MATLAB is also a product of MathWorks. So ThingSpeak, actually this platform can be used as an IoT platform, where you can send the data from your sensor data from sensor or controller or anywhere from data to your Wi-Fi module and then to the ThingSpeak platform. And from ThingSpeak platform, the data also you can you can aggregate, visualize, analyze, etc. All these things. And since ThingSpeak is available from MathWorks, and also MATLAB is a product of MathWorks, so data analysis part taking the data from the ThingSpeak IoT analytics platform, that can be done using MATLAB. That is possible. So by using ThingSpeak, you can collect the data, you can analyze data, you can act any trigger action. Okay. And ThingSpeak is such a platform that you can, it also enables to build the IoT systems without setting up any servers or developing any web software or like that. Very simple way. It can be, we can use the ThingSpeak platform. It is an IoT platform that uses channels to store data sent from apps or devices, whatever it is. So channels must be configured. Whenever you will be using ThingSpeak will have some different fields, field 1, field 2, field 3. All fields are actually connected with the field devices. Field devices in in automation hierarchy, you have seen. So in the field, suppose a lot of different field devices or sensors are there, say. So each sensor will be actually termed here as the field. Okay, field 1, field 2, or sometimes we call it as channel 1, channel 2, and so on. A number of channels are there, and the user will configure the channels for getting the sensor data into the ThingSpeak platform. Right. And you see that this is your, in this diagram it is shown any sensor or actuator or whatever it is. It is an IoT sensor because Arduino ESP8266 coupling is there. So this is sensor data. This is normal sensor, and after this, using Arduino ESP8266, it will actually convert the sensor into IoT sensor, and then the data will go to the ThingSpeak IoT cloud platform, ThingSpeak platform, through internet, and then again the data can be accessible by the user. This user may be anywhere in the world, and he can also access the data through this ESP8266 or Node MCU, whatever it is, and from there he can monitor the data, he can analyze the data, because MATLAB itself is usable by the user in the whenever the data is available from the ThingSpeak platform. So from this cloud, you can also use from this cloud the data can be analyzed by using MATLAB. So this is the advantage of using the ThingSpeak. And also in this case, the ThingSpeak data, the sending and receiving, all this done through application programming interface. That means application programming interface is that API key. So for sending the data, you need the API key. For getting receiving the data, also you need the API key. Both for receiving and sending. So without knowing the API key, the user will not be able to see anything from the cloud. So API key is basically ensures the safety of the data. Okay. And you see that how ThingSpeak in the field 1, field 2, different field devices are sending the data, and data is varying with respect to time, and that is visible with respect to time continuously. That the data variation with respect to time is visible by the user. That is, this data is received from the cloud. Okay. And you see that in your, say, one temperature sensor is being used in the plant area. So thermistor output, say we are using the thermistor. So if it is a ThingSpeak platform, this is the looking of the platform. Okay. So if it is a ThingSpeak platform, then the data will be actually changing with respect to time. So it is a graph. It is also called trend. Okay. So the trend line is basically indicating with respect to time how the data is being changed. The location of the sensor, geographic location of the sensor or channel can also be visible side by side. Okay, so you are observing the sensor data from anywhere in the world, but where actually the sensor is located, that is also visible from the location, channel location. That is also, that can be set by the user. Okay, and also this some IoT gateways are to be there. Here I have shown here one application program for using ThingSpeak using through LabVIEW. LabVIEW is also virtual instrumentation which we can use. That LabVIEW software can be used. I'm not going into detail into it, but here we can this type of software can be used also for sending the data through API key from sensor side to the cloud. Okay. Anyway, apart from ThingSpeak, Thingar.io That is another cloud IoT platform that can also be used. And here also you see that different IoT sensors or other devices are there, API keys are there. Through this Finger IO, the data can be available, data can be sent to the Finger IO IoT platform. From there, data can be managed, data can be analyzed, stored, etc. Okay, so all these are possible using also Finger IO. But in case of ThingSpeak, the advantage is that we can access MATLAB for analysis of data, because only data, visibility of data is not the objective. Analysis of data, optimization of data, all these things are also needed. So MATLAB analytics platform can also be used in case of ThingSpeak. That is the added advantage with the ThingSpeak, right? And you see that there are different types of programming, software programming can be used, and in the programming also we are using that API key. We have just mentioned that API key is an alphanumeric key. So you have to enter the API key in the software program for sending the data or for receiving the data. So if the software key, that is alphanumeric key, is not known, that is alphanumeric key for the channel number through which the sensor data is being sent or received, then if it is not known, the user will not be able to see the data. Okay, so this is the data safety, right? Now you see that this is actually use of IoT in the automation field. You see that there were several sensors, actuators are there. This is the field 0, level 0. Okay, this level 0, after signal conditioning, it is going to the microcontroller plus wireless connectivity. That means your ESP8266 module or this Wi-Fi module is connected with it. So after signal conditioning, all the sensors can send the data through API key through this cloud. So this can be done using through ThingSpeak or Finger IO, etc. And from the cloud, the data can be also accessible by the user from anywhere in the world, and that can be used for various applications. Okay, so this is your block diagram of multiple sensing controlling units with IoT capabilities. You see, this is the automation with IoT, right? And here also the same thing, but in a different way it has been shown. That means in the field some control operations are there, and also apart from that, is at the remote side of the field, there is also some accessible points are there. Say you see that here Arduino Mega with Wi-Fi capabilities there. If it is not there, then separate Wi-Fi module ESP8266 must be coupled with Arduino. And you see a lot of sensors are there. Several number of sensors are there in the process industry. Say gas sensor MQ6, temperature sensor LM35, any water level sensor. Any sensor data is actually going to this Arduino board, and from there it is actually the data acquisition board in one sense. So microcontroller unit is there for controlling the local devices. So output of that control is actually going to the driver circuit, and from there the driver is actually running the motor. And it can be also used for running this light source. Any buzzer for safety can also be there, and power supply is also connected with all these points. And these are the different access points which is available from your Arduino Mega. All these access points are there. From there, that is, these are the different channels. Access points means channels. Channel 1, channel 2, channel 3. All the sensors are connected in different channels of your ThingSpeak platform. And through this ThingSpeak platform, the data can also be visible from any mobile unit or anywhere, any PC or laptop, anywhere in the world. Okay. So this is the typical block diagram of IoT-based industrial automation system. Okay. And the same thing is also represented here. Your normal, apart from Arduino board, a normal Atmega microcontroller can also be used. Say different sensors are there, voltage, temperature, oil level, monostable, multivariate, anything is there. And this microcontroller board can also, after some interface or programming, they can be used, that is output can be used for any conveyor, any cooling fan, any pipe, pump, etc. And at the same time, the data can be sent to through ESP8266 to the cloud. You see that this from the microcontroller, the data through ESP8266. So this is actually your transceiver module. and through this transceiver module the data is going to the cloud, and any user can access the data of this controller. Any sensor data can be accessible by the user through this cloud, through the API key. Okay, so some programming interface must be there, and using that API key, and the user will be able to see all the data. The same thing here, we have used the Arduino Mega, so we can also use Arduino WeMOS. We can also use this Atmega microcontroller. Anything can be used, but this is ultimately the data will actually going to the ESP8266 to the cloud and then to the system. So this is your block diagram for IoT based industrial automation system, right? So so ways how IoT integrates into the automation, just salient points I shall tell. So first of all, it is giving you the real-time data collection, because IoT devices such as sensors and smart machines, etc., can collect vast amount of data in real time from various points in industrial processes. Then data analysis part is also there, that is IoT devices data collected by IoT devices is actually sent to a central system where the data analysis is done. So any analysis software algorithm can be used for analysis. And process automation and optimization, that is so many controllers are there. So on the basis of data, any controller tuning or anything is required for betterment, for efficiency, better efficiency of the machine, that can also be done, right? So these are the advantages, that is IoT integrates into the automation field. Any monitoring and control operation, any predictive maintenance, all these operations can be done. And applications where this type of IoT based industrial automation is used, it is used in manufacturing industries where your significant application of IoT is manufacturing, is quality control and assurance is there in the where the data inspection, manual inspection, rather than manual inspection, if it is done through IoT, and any remote operation or remote user can also analyze the data, and they can also visualize the data, and they can take the decision on the basis of data, right? And in this way, IoT is revolutionizing the manufacturing area by enabling real-time automated quality control, right? And one example is Siemens implementation of IoT in its electronics manufacturing plant. This is one example. And the company has equipped with production lines with a network of IoT sensors. Okay, sensors are basically distributed over the production lines, and their sensors will monitor the process in real time, and these sensors can collect various data including temperature, pressure, vibration, visual information, etc. Those data will be actually analyzed and deviations from the standard parameters will be actually calculated as a result, and this will reduce the waste of time. This will reduce the waste and ensure high quality and consistency of the final products. It is also used in agriculture, that is IoT is revolutionizing the agriculture through precision farming. Sensors can be used to monitor the soil moisture levels, crop growth, livestock health, and so on. Okay. And any logistics and supply chain, logistics is another field where IoT is making a significant impact. That is, take the example of DHL's smart truck. Here they are equipped with the vehicles with IoT devices, and thus they are able to track the real time to collect the data like traffic conditions, delivery schedules, all these things, right? And in doing so, they are able to optimize the route planning, and they can also reduce the fuel consumption, delivery time, and finally they will increase the efficiency and sustainability, right? And also your energy monitoring. Smart energy meters are actually IoT based smart energy meters can be used for measuring and monitoring the energy consumption from remote area. That is now suppose the person is getting the meter reading and he is going one home to another home, but actually smart meter is, if it is installed, then it is not needed to physically observe the meters, right? The data regarding the energy meter can be observed through the through IoT devices. Okay, so they can get the energy reading through the IoT based system. This will also increase. This will also increase the efficiency with respect to time and cost. Any automotive, that is IoT, is transforming automotive manufacturing and post-production services. For example, Tesla uses the IoT for vehicle production lines to monitor and optimize the processes. Okay, and they also use IoT in their electric vehicles to provide remote diagnostics, any predictive maintenance, and so on. And also, you know very well that IoT in healthcare actually is being also observed. IoT in healthcare brings about remote patient monitoring, any smart sensor, wearable devices, whatever data is being generated from these devices can be monitored by doctors from a remote location, right? And your impact of IoT on industrial automation, that is IoT is enhancing the efficiency and productivity, improved quality control is also there, increased safety is also there, that is environmental condition, safety with respect to environmental condition, any hazardous detection, or IoT also enhances workplace safety and so on. Better decision making is possible whenever IoT devices are connected, that is connected with some experts at the remote position, and his insights into the proper plant area, all these things will be helpful in strategic decision making. That is very much advantageous. And data security, privacy, that is also there, because your interconnectivity is the soul in the IoT devices, which means that data collected is transferred from one device to another. So data security is there. Previously, I have mentioned that API key is also a part which is ensuring the data security and privacy, right? Interoperability, that is with numerous IoT devices and platforms are available, which that means operability is, must be there, so that one device can communicate with each other without any physical hazards. Okay, so interoperability is also another challenge for IoT industrial automation. Data overload is also another challenge, that is, there are a lot of devices interconnected, so naturally the collecting the data, passing the data in the IoT environment, and the volume of generated data will be vast, and managing it is sometimes becomes daunting, right? And companies need to have the robust data management and analysis systems in place to make the most of this data, right? And you see, cost and complexity of the implementation is also there. Implementing the IoT in industrial automation can be costly but complex, and it requires significant investment in the new equipment, and also staff training is needed to have the proper operation. This is one challenge in the system, right? And with respect to safety and security, we should mention that though alphanumeric key, one API key is there, but if the key code is known to anybody, then they can also have the use of the data, and misuse of the data is also possible. So in that respect, it is safety and security with respect to data is also a very important challenge, which is to be met for IoT based industrial automation system. So in short, in conclusion, whatever we have discussed, that the relation between sensors and IoT in industrial automation, that I have already highlighted to some extent, and several companies are adapting these IoTs for their betterment, their better efficiency, better product quality, and so on, so that customer satisfaction is going to more, that is it reaches actually high. And also this is this industry 4.0 era has been possible through this IoT application in industrial automation system. Okay, so also training for existing persons of course is needed, along with the initial cost investment for the process plant for development, right? So thank you. If you have any question, please ask.
Thank you, madam. Thank you for this elaborate explanation regarding industrial automation using IoT, the most followed thrust area nowadays. And now say everyone knows that session is open to all. So all the participants, you can ask questions directly by unmuting yourselves to our respected speaker, Dr. Sagarika Pal. If you have any question, you can ask directly to the speaker.
You can
Okay,
also ask your question in
ma'am, one question is there. Can a 8051 microcontroller used in a simple IoT projects?
8051 is a microcontroller. You can use it, but IoT based project is basically is containing what that I have already shown in your block diagram, that microcontroller, any microcontroller you can use, but that after that microcontroller there must be one transceiver unit, that is your Wi-Fi module must be attached with it. Okay, so for that for that part, that is interfacing capability must be there. Okay, so if you use Arduino, normal Arduino Uno board, say, okay, there that connectivity, that interfacing is possible. So possibility of interfacing must be there. Whatever microcontroller board you can use, you should know how to send the data to the cloud. That part, if it is ensured, then any microcontroller you can use.
Okay, thank you, ma'am. But anybody else, if anyone would like to ask questions, you can unmute yourself and ask questions directly. Participants, is there any simulator where I can simulate IoT projects?
Full simulator? No. To the extent of simulation means only simulate your the voltage signals or to send it, but how will you implement that receiving part and transmitting part? That is actually should be in the physical world.
But ma'am,
Transmission
I
and
think one of the software is there, that is Proteus. Anybody can
yes,
use.
yes, that can be used, but how will you ensure that the data has been sent or data has been cloud, it is available? Is it ensured? Proteus, I have not used that software, but I have heard that. But is it possible? I do not know whether it is that is the actual sending and receiving part is contains a lot of things for these IoT based projects.
Yes, ma'am, it is possible because if we install VCP, virtual COM port in the machine, then it will work.
Mm-hmm.
It will work with the Bluetooth device and all these things. It is
That
possible.
means you are physically sending the data.
We are physically sending the data. Just we have to just point out the port which we are accessing for the this wireless communications. That we have to declare in that VCP COM virtual COM port.
That means
That's
your
one of the software.
that means you are actually using that software for interfacing.
Yes,
But
ma'am. Because one of the
software is
hardware
that
that software is having two port. One we
huh,
have to give address to from the simulation model,
hmm,
that is with the software that
hmm,
where we are actually doing the this diagram and where we are actually executing the program and
hmm,
all these things, and the hardware what we are using with which we are communicating,
hmm,
that
hmm,
should be connected to another port, and both the port we have to merge in a single software which is VCP virtual COM port. Then it is possible.
hmm.
Then they can go for this hardware simulation
Okay. And
IoT project.
also another thing is that you can use LabVIEW. In that case, LabVIEW is not totally simulator, but not simulator, but the virtual environment where you can take the directly the sensor data, or you can get the you can just get the data from random number generator, and from there you can, without using any Arduino board or any microcontroller or any transceiver unit, you can send the data from LabVIEW directly to the IoT platform. That is through
One of the software Budadito sir is also dealing. This is also one of the software WOKWI
WOK
online simulator is there.
online simulator.
It is also most importantly famous, very famous. While using this IoT, it can simulate. We can simulate IoT projects over there also. These are online simulator,
This is
open source.
online simulator. Okay, you are they are using your he is your colleague, I think. Budaditya Vishwas. You are using the data. You are using the simulator.
Okay, ma'am. Okay, I think no more questions from the participants. So thank you, ma'am. Thank you very much for being with us. And we, on
Thank
behalf of
you.
Honorable Chairman, sir, Honorable Secretary, sir, and Honorable Vice Chairperson of ICARE, and our Honorable Principal, sir, Dr. Bikramji Chaudhary, and Dr. Srimal Das, our Honorable Registrars as well. And I'm on behalf of Organizing Committee of RTE 2025. We are very much honored to have you with you. As we know that we're having a scheduled meeting from 3 p.m. onwards. So thank you very much. Within this busy schedule, we have found some time, and you have presented in such a in a very elaborate way and in a very brief mode also, because it requires more time to many of the slides has been skipped because of it requires
Yes,
more
time
time
is
to
very short.
actually present the entire scenario. So thank you very much for your time, and we hope in future, if we are planning to go for another any presentations or any FDPs or any staff development program, we'll be able to access you, and finally we'll be able to have you as a speaker in that session. Thank you very much for your time, ma'am.
Thank you all. Thank you.
Thank you. Okay, participants, we are keeping this active. Please fill up this form. Please fill this feedback form now here, because after from the evening, most of the time I usually get this request, sir, I was busy there. I understand everything. It's same for us also. We have some scheduled class, and this is the time 3. So either the class is over, or you are on a way to go to, or you are on the way for another class. So during this time, and I think 10 more minutes we'll be holding. Please try to fill up this feedback form as soon as possible, because otherwise later on it becomes really very difficult for us to manage. Because actually, honestly speaking, whoever is actually attending and whoever is not attending, this is very difficult now. At least later on we will inspect the same by comparing it with the Google datasheet, what the Google itself is, Google Meet is sending to us. So please fill this feedback form now, so that it won't create problem later on. And we are here to provide certificates to the participants. It's not that we are not in a mood to provide certificates to all, because we all are colleagues, we are working, we are with the same professions, we do understand each other's burden. And here most of the participants are over here. uh, Tomorrow also, and day after tomorrow is the last day. So on that day, you are already provided with the program schedule. You're having one talk on that day, and then vote of thanks, and having photo shoot and all these feedback formalities, whatever will be there. You have to follow that. Then later on, we'll provide you a overall feedback form and an assessment form, assessment Google form. There you have to attend that assessment, which is mandatory as per the registration form. And that will remain open active till midnight. So for faculties, as we understand this work burden and all these things, rest of the parts, we are not in a mood to close the form within half an hour, 1 hour. It is not like that. So we are on a way to give you a long span, so that